I want to show you a little bit of contrast here. This is what a bad day on Mars looks like. This was me and a colleague on the front page of the Los Angeles Times the day after the Mars Polar Lander crash, where we were appealing to a higher power to save our spacecraft and our mission. Unfortunately, it didn't work, but Phoenix was a whole different story. So this is a picture from the Arizona Daily Star front page. This is Peter again, and it was the day after landing, and we were outside of the Science Operations Center, and some reporters were outside, and they asked Peter what it felt to be a science rock star. And I think the question kind of caught him off guard, and he just went into this air guitar routine and started singing The Doors' "Come On Baby, Light My Fire." So it was pretty neat. Everybody was pretty giddy. I mean, everything was just going so well. So that was a great day. It really kind of exercised the demons and got the monkeys off our back from Mars Polar Lander days. Okay, so getting right into the mission here, Sol 0, these are the images we took right after landing. We didn't get them back right away. It took a few hours. But these are pre-programmed images that SSI took right after it deployed. So this shows our landing site right here, and you can see this polygonal terrain. So you see these kind of troughs and high points here. You can see the delineations. And this is due to the active freeze-thaw cycle that's in process here on the surface. And this is what we had expected to see. It was really textbook. And we had seen this from orbit, and you also see this, like if you go up to Devon Island, you see this all over the place. Anywhere where you have an cycle and not a lot of vegetation to interrupt it, you see this pattern or polygonal terrain start to appear. And so that was exciting. It wasn't unexpected, but it was neat to see that it met our expectations. And then a lot of the other images were actually engineering images. So this is a picture of the robotic arm showing that the biobarrier bag had deployed. Unfortunately, it got snagged a little bit. This actually delayed us for about a day. The robotic arm team wanted to wait to see if that would take care of itself. They didn't want to snag the bag as they were deploying the arm. And in fact, just the thermal fluctuations ended up making that fold off all by itself. We also had what we call the Neil Armstrong image, which showed one good foot pad down on the ground, which looked like we were on a pretty good stable surface. And then we had images of the solar panels to show that we were going to have full power for the mission. Okay, and then already on Sol 4, so that was Sol 0. Oh, I should also mention, I think probably everybody in the room knows, but a Sol is just our name for a Martian day. It's about 39 minutes longer than an Earth day, but we call them Sols. That's how we keep track of time on Mars. So Sol 0, our first day of landing. And then already on Sol 4, after the robotic arm team said, okay, we're ready to start moving the arm around and putting it through its paces, we said, well, first we have to go and we have to look at these other foot pads and make sure that we actually are on a stable surface. So we took the arm and we went over the edge of the lander deck a little bit and took pictures of this foot pad right here just to show that, yeah, we were safely on the ground. So it was a good image, it was an engineering image, but we were really surprised because there was something else interesting in the image, and that was this feature right here. You can see it a little bit in this image, but right here it looks like there's something smooth, highly reflective, high albedo object. In addition, this was directly below one of the thruster jets. You can see it looked like the thrusters had actually burnt a hole in something, and then a chunk of it actually got expelled out. You can kind of see where it hit the ground right here. So we were very excited by this image. Not only were we on a stable surface, but it looked like this thing that we had come 422 million miles to find, and we're really worried that we're going to have to dig and dig and dig and never get there. It was only an inch or two below the surface, and our thrusters, it looked like, had actually done a lot of the work for us already. And so we called this feature Snow Queen. I should mention that Peter Smith, the principal investigator, decided that the theme for naming things on the mission was going to be Once Upon a Time. So all the objects, all the features that we had or that we named during the mission had to come from either fairy tales or folklore. So a few months before landing, a graduate student was given the task of populating a Microsoft Excel spreadsheet full of names that were either from fairy tales or folklore and didn't infringe on a Disney copyright or trademark. And so we called this Snow Queen because obviously we had a pretty good feeling that this was the water ice we had come for. The other interesting thing to look at in this image obviously is this right here. I don't know if you saw it already. But this gave the alien bloggers quite a fit for a while, saying that there was obviously some kind of snail on the Martian surface. This was actually off of the spacecraft, And when the spacecraft engineers saw this, they were a little worried because depending on what it was, it could either be benign or fairly serious. We actually had to spend time to go back and try to get closer images of it with less compression using the robotic arm camera to figure out what it was. And it ended up turning out to be a spring. It kind of looks like a screw in this picture, but it was actually a spring. And based on the number of turns we measured and how big the spring was that we measured, the spacecraft team was able to tell us where it came from. And it was actually on the outside of that biobarrier bag. So we had gone through all that trouble to really sterilize things, and one of the more dirty things actually ended up springing off and landing right into the Martian surface. So it's kind of funny. Okay, so we're pretty excited. Sol 4, right? We see these images. We got these really what were intended to be just engineering images back. And the engineering team said, well, we still have to go take another look at that third foot pad because we haven't seen that yet. And of course, those of us on the science team said, we got to take a closer look at the Snow Queen feature because that looks really interesting. So we went back and we took some more pictures. And this was the closer up picture of Snow Queen, but this was the picture of the other foot pad. And we said, holy cow, when we saw that image. That's exactly what we said. It looked like, Snow Queen was interesting, but look at these features here on the other side of the lander. It looked like these very flat, very smooth, high albedo surfaces that looked a lot like the thing we had come all the way for. And in fact, they weren't very far below the surface. This is only about 2 to 4 inches below the surface. And so again, we were very enthused because it was a good indication we weren't going to have to dig too far to actually get to the water ice. And so we actually ended up naming this feature Holy Cow because, like I said, that's what we said when we landed, and it was on the list. We also tried to get color. Because this is just black. These are black and white images, and to really prove that it was water ice or lend more evidence to that, we tried to get color images, but we can never get quite close enough with the robotic arm camera using those lamps to pull out enough color information. It looked like it had a milkish white hue to it, but we couldn't be sure. The images were just a little too noisy when you tried to pull color out. Okay, so then on Sol 10, the spacecraft and management team said, all right, you're ready to go and acquire your first sample. And it wasn't really too critical where you acquired that sample. We just wanted to go and see if we could dig and make sure that the robotic arm could do the thing that it needed to do. So, actually, let me go back here. Yeah, Sol 7. This was on Sol 6. We decided to go and just acquire a sample from the surface. Didn't put a lot of thought into it. And these are 3 pictures of that first sample. So this was on Sol 7. These are all the same picture from the robotic arm camera, just at slightly different focus positions. I think the most in focus one is right here. So this was basically just taking a swath in the Martian surface, just one digging operation. And you can see, obviously we're very excited because we didn't even have to try really hard. And there's some more interesting white flecks. Okay, so then finally on Sol 10, we decided, no, let's try to actually go get our first sample for TIGA, which was one of these in situ instruments and our main instrument for detecting the water ice. So this was the first sample that we dug for TIGA, and we dug a little trench, and we called the sample Baby Bear. And again, we were real excited. This was a picture taken by the robotic arm camera before we dumped it into the TIGA. And it looks like we had a nice big chunk of something white there that we thought would be very interesting. So we went ahead and we told the robotic arm team, yeah, let's go ahead and deliver this sample to the TIGA. So on Sol 12, that's what we did. We took a picture to show that we had emptied the scoop, and here's the TIGA right here. You can see the doors were open, and we just dumped everything right on top of it. So TIGA, they said, great, we got a sample waiting for us. They commanded the TIGA to start vibrating the screen. There are screens over each one of these cell doors so that you only let small particles into the oven. And the screens were commanded to shake. Unfortunately, they were designed to shake up and down, which when you have a large mass load like this isn't really all that efficient. It would have been better if they shook side to side. But they commanded it to shake, and then they looked at the oven, nothing there. And they commanded it to shake some more, and still didn't see anything. It actually took several days. We didn't get the sample into TIGA until Sol 16. So we delivered it on Sol 12, and it took until Sol 16. Now this material was a lot different than what we had expected it to be. During all the simulations on the ground using the TIGA and using the robotic arm, we tried different Mars soil simulants mixed with various concentrations of ice. and sometimes even tried out salts. And none of that was as cohesive as this material appeared to be. This stuff just stuck together. No matter what we did,